Hello, JEE enthusiast. After a successful takeoff from kinematics and graphs, we are going to cruise at a stable altitude and the weather outside is really pleasant for performing our experiments. You may now proceed to take a leap and skydive. And skydive with your parachutes on, of course. So guys, good luck. Keep observing carefully the phenomena of free fall and welcome aboard. Welcome. How is everybody? Come on, let me know. Are you guys ready for taking that dive? Are you guys ready for skydiving? Are you guys ready to take that jump? How many of you are ready? Let me know in the chat box. Come on, I'm reading all your chats. Hello Space Talkies, hello Johan, hello Rishabh, hello Arijit, hello Papi Reddy, क्या बात है? Hello Hari Kumar, hello Johan, hi Rishabh, क्या बात है? Everybody is ready. I am very good, thank you very much. Hello Devi Randan, hello Hari, hello Sonal, hello Ayush, hello Abhishek, hello Tharmi, hello Hridyam. Oh my god, the chats are going up so quickly. Look at the smileys, look at those hearts. Oh my god, I'm so overwhelmed. Welcome aboard, welcome aboard. Welcome. You know what happened yesterday? We were all saying, how is the Josh? How is the Josh? And there was a guy called as Josh and he was wondering why the hell are we taking his name? So Josh is the name of a person out there. Okay. Well. Interesting. How is everyone? How is everyone? Well, Toheed, I'm very good. What's up? Hi Abhishek Chaurasia. Hi. Very good. Very good. Hello Hemlata. Lots of love. Thank you so much. Hello Siddesh. Hello Yash Jain, hello Saurabh, hello Sonal, hello Badal, hello Sambhav. Oh my god, look at your lovely comments. Look at those hearts, look at that fire. Somebody is putting fire out there. Hi Deepak. Welcome. So how many of you have done skydiving? Let me know in the chat box. How many of you have actually done skydiving somewhere? Maybe in Kulu Manali, maybe somewhere outside India, maybe, I don't know, some place. How many of you have done? Let me know. Come on. Well, Pandu is very nice. Arjit. Okay, not me, says Jayant. Okay. Oh, a lot of you have done, some of you have not done. Okay, I hope sometime in your life at least, you will definitely skydive and you will have a time of your life. It is very, very amazing. Okay, so I will tell you a very interesting fact. Are you guys ready for a very, very interesting fact? And those of you who already study under me already know that I have this very good or bad habit of cracking these amazing jokes, which are so-called PJs by most of them. But anyways, I'm going to crack it. So guys, do you know you can skydive? This is a very important fact. Listen to me carefully. You can skydive without a parachute. Yes, you can skydive without a parachute, but only once. Yes, you can skydive without a parachute only once. I hope you understand what I mean. Okay, Harshita is laughing out there. Kya baat hai? Well, Devas, that's my Enthuse and that's the energy that I receive from you. It makes me do all the classes. Very good. Okay, nice. I hope you guys understood it. Amazing. Look at the comments. Thank you, Vasudevan. Well, Hari. Hello, Hemlata. I hope you guys understood that you cannot skydive twice without a parachute. Okay, so having said that, welcome guys. This is Shreyas here, your master teacher for physics at Vedantu, going live from the Bangalore studios. And like most of you know, I've been teaching for quite some time and many of my students are already in IITs, NITs, BITS, you name it. And I really hope that we enthusiasts are going to reach there very soon, whether you are in 2021 batch or 2022 batch or 2023 batch, doesn't matter. We all are enthusiasts out here who want to crack the most difficult examination, and I, Shreyas, I'm going to make sure that you do it. Okay, so welcome aboard everyone. No problem, Navami, even if you're a dropper, it's okay, no problem. And I know some of the NEET students as well are here, no problem. It doesn't matter. Physics is physics. Be it in NEET, be it in JEE, be it in boards. It's the same thing. Okay, thank you. Oh, somebody from Japan is also here. Wow, look at that. Okay, so it's very important, guys, you understand what we are doing over here. We are selflessly devoting We are selflessly devoting ourselves for you guys. So it's very important that you spread the message around. It is just going to cost you 0 rupees to just go and hit that subscribe button, just share it and like our videos. It's going to cost you nothing. It's just going to cost your love, your affection. That's it. Nothing more, nothing less. Why should you subscribe? Because you will not get notified otherwise. When is the next session? When is the next assignment coming up? When is the next quiz coming up? When is the next amazing lecture going to come up? You will not get to know. So that's why it's very important you hit the subscribe button right now, or else you'll miss out on all the important notifications. Why should you share? Because there are so many kids who do not have access to proper education. They do not have access to quality education. You should be the brand ambassador, guys. You all are ambassadors of this channel, and you are going to definitely share and spread the message on your social media accounts as well. I'm pretty sure. And why should you like it? Because what is the secret of my energy? Come on, let me know in the chat box. I'm reading it. What's the secret of my energy, guys? What's the secret of my energy? Okay, come on. Yes, yes, yes. Okay, yes, your love is the secret of my energy, and you can show it over here. So do not forget to like the videos. Okay, amazing. It's not attendance, guys. It's not just attendance. I'm here for your love. If you attend and you're mentally present somewhere else, it's of no use. You have to love all of us. That's why we are here. Okay, so let's begin. Oh my God, somebody is in 8th standard, 2024 batch, 2023 batch. Wow, 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 amazing. Okay, thank you, Deepak, all about Tech Tamil. Hi, Space Talkies. Okay, Apur. No problem, Apur, even if you are in 10th. So this is the weekly schedule. Have a look at it. This is this week's schedule. We started yesterday with kinematics and graphs in 1D. Then today we are going to do motion under free fall. Tomorrow we're going to do derivatives and so on and so forth. Do not forget that tomorrow morning we are going to discuss the assignment which I'm going to put up in the description box below. Yes, it's going to come up after some time, not now maybe. And you have to solve that assignment tonight, and probably you can say take some more time and solve it by morning. The discussions will be up tomorrow at 12 o'clock sharp. Okay, so keep a look at it. Keep looking out for those solutions. These are proper video discussion solutions. Yes, you will get it in the Telegram group too somehow. Yes, you will get it. Yeah, you will get it in the Telegram group as well, and I'll share the links in some time. But understand, it's very important that you solve these questions. We are going to discuss some amazing questions I have put up in those assignments. You have to solve them. You have to solve them. You're going to have fun. Okay, that's something I can assure you. Okay, so let's start. Yes, let's start, begin. Let's start, guys. What say? Yeah? Okay. Yes, I'm healthy. Thank you, Chini, so much. Yes, the drills, everything is there. The drills are your assignments. The drills are your assignments. Okay, let's begin. So quick revision of what we did yesterday. V is u plus at is your first kinematic equation. V square is u square plus 2as is your third kinematic equation. Okay, the order is up or down, doesn't matter. S is ut plus half at square, generally is called as the second kinematic equation. And I also gave you a bonus equation, which is also called as the fourth kinematic equation. And we all know what it is. It is nothing but the displacement in the n second, and it was Sn is nothing but u plus acceleration divided by 2 into 2n minus 1. That was your fourth kinematic equations. These equations tell you what is the velocity, what is the displacement, how much is my displacement in the n second, etc., etc., provided other things are known to me. And be careful, you cannot use this equation anytime, only when the acceleration is constant. That's something I told you guys. Yes, remember? Okay, do not worry about electrostatics. We are going to do it soon. A lot of you are asking when are we going to do 12th standard and all that. Do not worry, guys. We are going to come up with the entire syllabus portion. We are going to complete it. So just go with the flow. Even if you are a dropper batch student, just follow my flow. I have planned it so beautifully that you will be able to revise everything. Let me assure you that. Okay. Now, having said that, let's go ahead. Very famous experiment. Some of you might have watched this video as well on YouTube or somewhere else. Galileo performed this experiment hundreds of years back. And he came up with this idea that, no matter how heavy an object is, it will fall down at the same time. And this experiment, when performed in a vacuum chamber, gave those results. So if you take a heavy stone and a light feather, like you can see guys over here, look at this. The heavy stone and that light feather fall at the exact same rate, no matter what their mass is, provided there is no air resistance. The moment there is air resistance, that's it. Things get messy. Air resistance depends on their shape, size, etc., etc. And you will see that you will not get the same time. And in JEE, we are going to make the assumption 99% of the times that there is going to be no air resistance. So that's how JEE problems are going to be. So understand, 99%, unless specified otherwise, you will not have air resistance. So we'll be dealing with air resistance in a separate chapter. There are some simple problems on it in a chapter separately called as viscosity. So do not worry about it right away. Okay, let's keep things simple. Okay, so no matter what the masses are, first point, what are you writing down? I hope you guys are making notes as well as I speak. I hope you guys are making notes. Come on, keep a paper ready, keep a pen ready, because you have to solve problems. Please keep, thank you Prasad, yeah, please keep writing, please keep making notes right away. Okay, so no matter what the mass is, the objects fall at the same rate. Now, why do you think this happens? Why do you think this happens? This is because you might think, oh, a big mass will probably maybe fall very fast because it has more force. Think about it, a bigger mass will experience larger force, but it also has larger inertia. So they compensate each other. You might think, because gravity depends on the mass. So more the mass, more the force. Yes, correct. But more the mass, more the inertia. So they compensate, they balance each other, and you will see the acceleration is independent of the masses itself. Okay, so remember that. Another thing, a lot of people think free fall motion. Let me tell you, keep your eyes and ears open now. A lot of people think free fall motion means just falling down, just keep on falling down. That is free fall motion. I hope you have watched Simpsons, so you know who this character is. So free fall, well, this is free fall. Yes, I drop this pen, that is free fall. Okay, what about this? What do you think, guys? Oh my god, what do you think, guys? Is this a free fall motion? Is this also a free fall motion, going up and coming down? What do you think? Yes, it is enough for advanced 2. Yes, Anish. No? Well, Arundhati, wrong. Think again. It is a free fall motion. Going up and coming down is free fall motion. So guys, understand, any motion which happens only because of gravity alone is called as free fall motion. Understand this. Yes. Even if I throw the pen like this and it goes here, if I throw it like this and it goes here, this is also free fall motion because the only influence it had was gravity. So it is a free fall motion. That's it. It does not mean it has to fall down only. Even while going up, it is free falling. Yes, even when this pen was going up, it is said to be a free fall motion. Please keep this in mind. If you have read it somewhere, oh, this is not a free fall, this is free, I don't know what is the opposite of that, but free jump motion or free up motion. No, that's not correct, guys. This is also a free fall motion. Please understand that. Okay, now the next point. Well, yes, it is called projectile motion, but it is still a free fall motion. Understand that. Okay, so I hope you get that. So going to the next point out here. So what is the rate at which these objects fall? What is the rate at which these objects fall? Well, when I'm throwing it, yes, it is not free fall because I'm applying a force, correct? But once it leaves my hand, only then it's a free fall. And when I catch it also, it's not free fall because I'm applying a force. Only when it is not in contact with anything, only that time it was a free fall. Well, it is not 9.8 meters per second. It's not velocity, Tejas. Think again. I'm asking you the acceleration. The acceleration of all the bodies, guys, is 9.8 meters per second square. Okay? All the bodies, irrespective of the masses, they get pulled towards the center of the earth with an acceleration of 9.8 meters per second square, though this value changes depending on place to place and stuff like that because of the unevenness and the rotational effects of the earth, but let's take it as 9.8 as an average. But you know what, J is very cool. So they say, okay, you know what, the calculations become really messy when you use 9.8. So why not take this 9.8 for easy calculations? Just 1 second. Okay, so why not take this 9.8 guys as 10 meters per second square approximately. So this is 10 meters per second square approximately. And let me give you one more trick. This is very important for solving problems. You can write this value as approximately pi square. Yes, pi square meters per second square. This is very useful for JEE Advanced and Mains problems. Lot of times pi is there somewhere and you want to cancel it out, or sometimes the calculations become very lengthy. If you use pi square as G, it becomes really simple. So remember that. Okay? Okay, so that's one approximation which you're going to remember. Okay, let's go ahead. Now, let's start solving problems. Get ready guys. I hope your pens and papers are out. You also should derive as and when I derive if you want to, or else you can always watch the replay, but still pay attention, keep scribbling, keep making notes, whatever I'm saying. Now, look at this. There is an object which is dropped from some height. Okay, that height will be given to us. What is the velocity with which it hits the ground? Let's use kinematic equations for getting this answer. Why? Because acceleration is constant. Great. Now let's think about what and all do we know about this. Okay, so let's see. 1 second. Okay, so now because it is mentioned that it is dropped, this word dropped means that the initial velocity, okay, what does this mean? It means the initial velocity is 0. Keep this in mind the moment that word drop is used. Next, where is the acceleration going to be? The acceleration due to gravity is going to be vertically downwards. And how much is it? G, and G is approximately 10, but we are not going to substitute the value. We are just going to keep it as G itself. Okay, so it's going to accelerate downwards with G. If you want, we can substitute, but later on we can do that. Now, the height, well, this height, say for example, is height h. Okay, this entire height from where it is dropped till where it reaches the ground, this entire height is h. Okay, now what do I want to find? What is the velocity with which it hits the ground? Okay, so just before it hits the ground, it will have some velocity. What happens after that is none of our business, because there is a separate chapter which will deal with it. Collisions, yes, it depends on the different types of collision, what happens after the collision. But right now we are just concerned about this motion right from the beginning till the end. Let me call this velocity as v. Okay, now I know I want to know v. I know the initial velocity u is 0. I know the acceleration, I know the displacement. Which equation should I use? Come on, bolo. Yes, most of you have already got the answer. Excellent, Arundhati, Papi Reddy, Tejas, very good. There are some people who are probably new, so that's why I'm going to derive it. Don't worry. So using v square is u square plus 2as. But hold on, I forgot one thing. I forgot what side should I take it as positive, what side should I take it as negative. What should we take it as positive? Which direction do you want to take it as positive? Which direction? Come on, let me know in the chat box. Kya baat hai, Shivangi? You're from BT Pune. Wow, very good, very good. Okay, upward. Okay, let's take upwards as positive. No problem. Okay, let's take upwards as positive. So, if you look at it, the final velocity is down. But don't worry, this is squared. So anyways, that sign will not matter. Okay, even if I take it as minus v, it is going to get squared, guys. So it doesn't really matter in this particular situation. Okay, next, u is 0. Great. Plus 2 into acceleration. Acceleration is down, right? Acceleration is down. Okay, so acceleration is down, so that means it should be minus g. Understand that, because I've taken upwards as positive. And what about displacement? Think about it. What about displacement? Should I take it as h or should I take it as minus h? Come on, tell me. Should I take it as plus h or minus h? Yes, minus h. Why? Because this was my initial position and this was my final position. The vector, displacement vector is down. Think about it. Initial to final, it's down. It's opposite to our sign convention. So that's why I'm going to take it as minus h. Now minus minus plus, and this minus square is also plus. So therefore I'm going to get V square is 2GH, of course, and therefore V is nothing but root of 2GH. That is our final answer. This is something which you are supposed to remember. V is root 2GH. V is root 2GH. If you change your planet, if you change your home to moon, G will change, this speed will change. If you go little bit higher, H will be more, the speed with which it will hit the ground will also be more. Okay, I hope this is clear. No. So the height is not negative, displacement is negative. And the magnitude of displacement is H. So the value that you put over here should be the value of the displacement. That's why it is minus H. Okay, I hope this is very, very clear. Amazing. Yes, just one, if you go to Mars, the value of G will change and the speed will be different. So lot of schools, lot of people have told this, that when you go up, G is negative, and when you come down, G is positive. Oh my God, this is not correct. No, that is wrong. How the hell does G change the sign when you go up and when you come down? G is always down. G is always down. Understand this. How do you then decide whether G is positive or negative? Understand, it depends on which direction you take as positive. It's up to you, not up to the book or somebody else. Yes, understand this. So if some Pandu takes upwards as positive, for that Pandu G is negative. If Champa takes downwards as positive, for that Champa G is positive. I hope this is clear. I hope this is clear. Just once in space, gravity will be 0. Okay. Very good, Abhishek. Thank you. Very good. Anumit, Navmi, very good. Very good. So let's go to the next derivation. Let's get ready, guys, to the next derivation. Okay. Now, same situation. The only difference is what is the time? Okay. What is the time taken? So, which direction do you want to take as positive, guys? Upwards or downwards? Last time we took upwards as positive. Let's take downwards as positive. What I want to do is to prove to you that it really doesn't matter what direction you take as positive, what direction you take as negative. Yes, it doesn't matter. This time we are going to take downwards as positive direction, and we'll see whether it makes a difference. It won't. And if you're scribbling, you will see that it will actually not make a difference what direction you take as positive or negative. Okay, so let's see what and all do we know. Initial velocity 0, okay, and it has come down by a height h, and displacement. What is the displacement now? Think about it. The displacement will be plus h, because this is the initial point, this is the final point. Initial to final vector is niche, so displacement is plus h. Acceleration, well, think about it, guys. Acceleration is downwards, and since downwards is positive, obviously you have to take it as plus g. Okay, so please understand, I have seen so many people ask me these questions. Sir, isn't g negative? G value is minus n. No. G is a number, and what it, just like pi is 3.14, same way g is also a number, 9.8 or 10. So you have to put sign ahead of it, not in g. G does not have sign. G is always positive number. Yes, you have to learn these formulas, Jai. Yes, correct. So which equation do I use? I think I'll use the second kinematic equation. What is it? S is ut plus half a into t square. Okay. So now what is S? It is nothing but h. What is u? 0. Oh, this term vanished. Great. Plus half into acceleration, that's g, into time square. This time that I will get will be called as the time of flight. So I'll put it as capital T. Okay? So this T that you are seeing over here, this is called as the time of flight, not the time of your life. That's a song anyways. So h is half gt square. Let's rearrange this, guys, and let's put 2 over here. Let's bring this guy down. So it will become 2h by g is equal to t square. Therefore, t is equal to root of 2h by g. That's your final answer. I hope this is clear. Aryan, don't worry about the syllabus. First, concentrate here. Yes, remember this formula. If you go on moon, g reduces. Yes, g reduces. and the time of fall will be very large. It will fall slowly because G is downstairs. If H increases, matlab you drop it from a very tall tower, it will take long time. H is upstairs, so time increases. I hope this is clear. Isn't it wonderful? Are you guys enjoying? Please let me know. Why not V is U plus AT? Yes, you can use that, Devas. Why not? You can use it. But I felt that this was easy because in V is U plus AT, you need to know V from the previous thing. Without any another equation, I have got this answer. Amazing. Thank you, Prasad. Thank you, Isaac. Wow. Thank you, Krito. Thank you, Varsha. Okay. Thank you, Harshni. Thank you, Hasni. Okay. Bye. Okay. Let's go. Okay. Let's go to the next one. Now, we are going to take the next case. You throw a ball up, it goes up and comes down. In this motion, when it reaches the topmost point, what is the velocity? The velocity is 0. Yes, Madhvi, I'll take your questions. Maybe you can put it in the comment box. Okay, the velocity is 0. Why? When it is thrown up, it is thrown with a very large speed. The speed reduces, becomes 0, and then the speed increases as it comes down. So there is a moment, just a small moment, very small moment. It's an instant when the velocity is just 0. It's not even 0 for 1 second or 0.1 second. It's 0 for an instant. That time is very small, not perceived by human beings, but it's small. It's there. That instant, it is at the highest point. That's the farthest distance it goes from the ground level, and after that it comes back. Okay, great. This is one thing you should remember, because now we are going to use this fact for solving the problem. Okay, now imagine this guy. He throws an object from the ground with a velocity u. What is the height of the topmost point from where the ball is released till where it reaches? Okay, what is this topmost point ka height from the ground level? I want to find that out. So let's do this. It's not that difficult. Let's assume okay, 1 second. Wow, you need to be nice and gentle to this guy, else I don't know. Okay, please don't change. Yes. Oh, it keeps changing. I can't help it, guys. There is some bug sometimes. Oh, thank God. Great. Okay, so we have the initial velocity u, and g is down, and when it finally reaches the max height, remember the velocity is 0. We just discussed this. This is your max height h, and we want to find this out. How do we do this? Which equation? There are many ways of doing it. Let's use third equation because I feel that will be the easiest. Let's do it using the third kinematic equation. What is it? V square is equal to u square plus 2as. Let's use this. What is V? V is 0. Okay. What is u? Please understand, a lot of people feel, sir, when I throw the ball, sir, the velocity is 0. No, it is not 0. This u is that speed when the ball leaves your hand. Yes, when it is not in contact with your hand. So initial velocity is not 0. Please get that thing. Okay. Anyways, so u is u. It's not 0, plus 2 into acceleration. Where is it? It is downwards. So which direction am I taking as positive? Let me take upwards as positive, guys. If I take upwards as positive, g being down will be negative. So it will be minus g. H, what should I take? See, this is the initial position. This is my final position. The vector will be upwards, not downwards. So it should be positive because upwards is positive. So it should be plus h over here. So take these people over this side. So this minus will become plus. So you'll get it as 2gh is equal to u square, and therefore h will be equal to u square by 2g. So that will be the maximum height reached by the projectile. And it makes sense. See, guys, what I have been telling you, you have to get the feel of the situation. You just can't derive this formula and forget it. Oh, let's go to the next problem. That's not what we are going to do. Think about it. If you go on to the moon, g is less, h will be more. That means you throw the ball with the same speed, it goes much higher. And if you go to Jupiter, like planet, where g is large, g being large, denominator increases, h will be small. Also, if you throw the ball with higher speed, it goes really high. And very interesting thing, if let's say you throw the ball with some speed u, it goes till some height and comes back. Now, if you throw the ball with 2u speed, it will not go with to a height of 2h. In fact, it goes till a height of 4h, because h is proportional to u square. Yes, it is proportional to u square. Think about it. So, if you double the speed, the h becomes 4 times. If you triple the speed, h becomes 9 times. Yes, you can derive it using k is equal to p, but I have not yet reached there, so that's why I'm not using those things as well, Jai. Okay? Yes. Okay. Now, let's go to the next point. Let's go to the next point. Let's talk about what is the time taken to reach till the ground. So let's do this. Time taken to reach till the ground. 1 second. Okay. So to find the time taken till it reaches the ground, I'm going to use some innovative methods and you're going to see how well you get the answer. Okay. Now, the initial speed is u. The acceleration due to gravity g is down. It goes up, reaches the maximum height and comes down. Now, when it comes down till this point, the total time that has elapsed is capital T. You started this event at t is equal to 0. This total time is my time of flight. You have to remember this formula which we are going to derive. Yes, we can use the second kinematic equation. Now, if I use the second kinematic equation, I need to know what is the displacement. Think about it. What is the displacement? If I want to use S is ut plus half a t square. For this entire journey, what is the displacement? Think about it. 0 displacement. I'm not asking you distance. Distance will be 2h. Yes, correct. So it will be 0. What is u? Oh, I have to choose some positive, negative side. I forgot that. So let's choose what is positive. Let me choose upwards as positive. So u being upwards, I feel that we should take u as plus u only. Great. T, I do not know. Plus half. Acceleration, well, it is downwards. So I should take it as minus g into t square. Now you have been learning. You have been learning about quadratic equations. Isn't this a quadratic equation? I'm coming to that, Hari Kumar. Wait a second. Yes, think about it. Yes, it is a quadratic equation. It has two values. Take time outside and you will see it will become u minus gt by 2. Interesting. Now what do we do? Oh, this into this is 0 means either this is 0 or this is 0. That's what you have studied in quadratic equations. So that implies t is 0 or maybe both the solutions, or this thing u minus gt by 2 is 0. Now if I solve this, I'll get, therefore u is equal to plus gt by 2. Put that 2 up, put that g down, you will get t as 2u by g. Now why am I getting two values of time? Why am I getting two values of time? Because no, t can be 0. Yes, we are going to come to that, Gopal. Yes. See guys, the significance of quadratic equations is seen here. That's why it's very important to learn maths as well. This quadratic equation doesn't know what we are trying to do. If you put some values, it will just give you the output. What is given as the input to this equation? Yes, when is the displacement 0? See, displacement 0. Quadratic equation is just going to solve itself and it is going to give me two values. But what it means is understood by physics. Now see this. See this. When displacement is 0, time is also 0 initially. Initially it has not yet started its journey. That's the exact moment when displacement is 0, time is 0. And when it goes up and comes back, even then the displacement is 0. So it is telling me that the displacement is 0 twice. The displacement is 0 twice, guys, once when you just start it and once when you come back. But which value do I need? Now this I understand by logic, by applying common sense. You cannot blindly say, sir, both the times are allowed. No, the value that I am going to choose is obviously 2u by g, because I know that's the time which is more useful for me. So this is something which you are going to remember. Okay? Yes, Devash, I'm going to come to that. Well, this is the total time, not just going up and or coming down. This is going up plus coming down wala time. Okay, this is total time. Okay, I hope this is clear. Yes, Krito, bahut hi badhiya, very good, Arundhati, very good, Karan, amazing. Thank you, Arundhati, thank you, Mohammad, thank you, Vijayan, thank you very much. Okay, thank you, Arni. Okay, great. Shall we go to the next thing? Okay, now let's go to the next part. But before going to the next part, let me tell you, there was another interesting way of solving this same problem. Yes, probably you did not realize it, and I'm going to show it to you and blow your minds. Yes, observe quickly. Let's do this quick. Initial velocity was u. It goes up and comes down. You know what? When it comes back, its speed will still be u only. Yes, it's not that its speed will be less or more. Why? Because there is no air resistance, so there is nobody to suck away that energy. So when it goes up and comes back to the same point, its speed should be same. Think about it. It cannot be different, because while going up also it was decelerating at the same rate, while coming down also it was accelerating at the same rate. So it's the same situation, just reversed. So hence, understand the speed with which it comes back to the same point will be 0. Okay? So if you allow it to come back till the same point, yes, its speed will be 0. So why not use v is u plus at? So what will be the value of v? Think about it. The final velocity. What do you think the final velocity will be? Think about it. The final velocity will not be u, but it will be minus u if I take upwards as positive. This is the final velocity. This is final velocity and this is initial. So it is minus u, think about it, because the direction is niche, and u, which is the initial velocity, is going to be just plus u, and a is obviously minus g into t. Okay, now let's do one thing. Let's take this guy over here. So it is going to become gt is equal to, this minus will become plus there, so it will become u plus u. So therefore t will become 2u by g. Isn't this the same answer what we got before? What my point is, there are so many ways of solving the same problem. So it's just that you have not explored it yet. You have to explore. And what my intention is to show you some ways of exploring different different equations, different methods. Maybe I might not show you everything, but I will show you this is the way. You have to lead it, you have to follow it, and you will be mind blown for sure. Okay? Yes, Gopal, we are come to graphical ways also. Just hold on a minute. We are going to come to that. Okay. Well, somehow it depends whether you allow it to reach the ground or not. Okay, it depends. Amazing. Okay, let's go to the next part. Now, these are the properties which you should remember. Symmetries in projectile, because in the assignment which is going to be shared in the description box below, you will be seeing questions on all those topics, whatever I have taught you today, right from the beginning till the end. So pay attention, guys. Yes, symmetry property. So remember this. At any point of a vertical free fall motion, okay, at the same height, the speeds will be same, just that the direction will be different. So understand, at this point the speed might be 5, at point B also the speed will be 5 but downwards. But at some other point, maybe over here, the speed will be different from A. But at this point and this point, the speeds will be same. Understand that. Okay? So at the same levels, the speeds will be same, but the directions will be opposite. If you go at a higher level, the speeds will be less, but those two speeds while going up and coming down will be same. Okay, so projectile, what is the meaning of projectile? Projectile means anything which is just thrown, that's called as a projectile. It need not be at an angle. Understand guys, even this motion, just throwing this pen up, is also projectile motion. It's a special case where the angle of throwing up is 90 degrees. That's all. Understand that. Yes. So that, Madhvi, brings me to the second point, that the time of ascent and the time of descent both are same. Time for going up and time for coming down will be same. So guys, the total time for going up and coming down was 2u by g. So what will be the time to just go up? Think about it. Think about it. If this is true, because of symmetry property, it will be just how much? Come on, answer in the chat box. Yes, Mohammed will do that soon. Very good, Papi Reddy. Very good, Chari Kumar. Very good, Devars. Very good, Diyar Ridyam. Very good, Mohammed. Very good, Kirto. Very good, Varsha. Very good. Very good, Sambhav. Very good, Kirti. Very nice. U by G. You guys have understood this. Amazing, Arun Harikumar. Very good. Very good. Anumit, Tasmiya. बहुत ही बढ़िया. Siddharth Jain. Very good. Somebody's name is Isaac. क्या बात है. Very nice. Now let's do a problem. Are you guys ready for a problem? How many of you have seen this cartoon? Let's do a problem. Let's start doing problems. We have seen so many formulas. We have seen how to use kinematic equations. Okay. Yes, yes, yes. So the thing is, we are going to drop a rock from the top and we are going to see how much time it takes to fall down at different points, and you are going to see how to solve problems. So pay attention. Let's see how to do the problem. Okay, so rock is going to fall from the top and the rock is 100 meters above the ground level. How long will it take to reach only the first 50 meters? So let's start solving the problem. If you are having a pen and paper besides you, please start solving right away. And once you get the answer, you can start posting it. Come on, come on, come on. Start posting it. Yes, Bharat, there will be soon, but not now. Okay, okay. How long will it take? Acha, let's see whether you guys are correct or wrong. Okay, here is the thing. How long does it take to reach the first 50 minutes? First 50 meters. Now, because it is dropped, the initial velocity is 0. Now, once it comes down by a height of 50 meters, right? Think of it. Forget the rest 50 meters for now. Think of it as if you're dropping it from a tower of height 50 meters. And we all know which formula we can use. Which formula do we use? Remember, I just gave you that formula some time back. Dropping a ball from top at height h. What was that formula? T is root of 2h by g. Okay, great. So what is h over here? Think about it. What is h over here? Is it 100 or is it 50? It is. Yes. Now, Garima, you are giving the correct answer. Very good, Anumit. Yes, a lot of you are wrong initially. Very good. H is just 50. Correct. H is 50, not 100. Next, what is G? We'll take it as 10. We'll take G as 10 for making calculations easy. So, come on. 2 5s are 10. That 0 goes. So, it is just root of 10 seconds, guys. Yes, the answer is root of 10 seconds. Oh, damn. Yes. Kirito, oh, damn ho gaya. Yeah, it is root of 10 seconds. And in the options, you'll have root 10, 10, 5. All these options will be there. And most of you would have got it wrong. So please read it carefully. Okay. Shall we go next ahead? Shall we go ahead? Root 10 seconds is the answer for the first 50 seconds. Okay. Great, great, great. Now let's go to the next part of this question. Read it very carefully and let's see who gives the answers first in the chat box. Okay. So if you want the exact value, it will be 3.16 seconds. And do you remember what did I say just some time back? Do you remember? What is G or 10's root or root G's root? Think about it, because I just said pi square is G or 10 approximately. So root of 10 or root of 9.8 approximately will be around the pi's value. So it is around that value, just a 0.02 difference, but that's okay. But you get the point. Okay, correct. So it will be pi, because understand pi square is 10 approximately, very approximately. Correct. Very good. I see so many intelligent students out here. Yeah, very good. Very good. Very good. Now, how long does it take to cover the rest 50 meters? Oh, this is interesting. How long does it take to cover the rest 50 meters? What does it mean? Let's try to understand this problem first. Okay, let's keep this guy out here. Now, this is the initial velocity 0. It traveled the first 50 meters and then more 50 meters till obviously it hits the ground below it. The first 50 meters, we just found it out that it took root 10, which is approximately equal to 3.16 around seconds. Now, I know a lot of people are answering, sir, obviously it will take the same time. This is 50, root 10 seconds, next 50, obviously root 10 seconds. Guys, if you have attended today, today morning's session of drill discussion, you know that in accelerated motion, you will see that the displacements are not equal. Yes, in the first second, third second, they are not equal. Yes, they are different. Correct. Very good. They are different. So, how do we do this? There are many ways, of course, but let's use the formulas that we have got today. Very good, Siddharth. Very good. Very good. Very good. So, what we'll do is, why not consider the entire motion? Consider the entire motion from here till here. This is 100-meter drop. This is 100-meter drop. And let's try and think, for this entire duration, how much time do I take? Which formula do I use? Root of 2h by g. So I'll use time is root of 2h by g. Okay. So now, what is the value of h? Obviously, h is 100 meters. So put 100 over here. And what is the value of g? Okay, the value of g is 10. So put 10 over here. So what will I get? 0, 0 cancels. 2 into 10. How much is it? 20. So root 20 seconds is the answer. But this is for the entire time. So this entire duration takes root 20 seconds, guys. Now this takes root 20 seconds. This takes root 10 seconds. So how much will this take? Think about it. How much will that take? So this part, this much part, guys, how much time will it take? Very good, Garima. Very good. Very good. Very good, Arundhati. Very good, Papi Reddy. Very good, Tasmia. Very good. Very good. It will take root 20 minus root 10 seconds. Exactly. Please do not write it as root 10. It's not the same. It's not the same. Root 20 minus root 10 is not root 10. Please please be mindful of that. Very good. How nice this problem was. An interesting thing, guys. By the way, let me tell you the answer for this. If you calculate, it comes out around 1.31 second. Now it's very interesting. Pay attention to the details. The first 50 meters took 3.1 seconds. From here to here, the first 50 meters took 3.1 seconds. But the next 50 meters have just taken 1.31 seconds. Very clearly, it tells me that as you accelerate down, the speed increases, the further displacements that are undergone are going to happen really quick because you have already achieved that velocity. Yes, correct, Jan. Yes, you are gaining that velocity. So that's the reason why you're taking less time as you go ahead. Very good. Very good. Did you guys understand in depth what I said? Excellent. Excellent, Anumit. Very good. Very good. Okay. So let's do this question. This is very exciting question. Read it carefully. Very good. Let's see this. Two balls are thrown simultaneously with the same speed. Very important. If I throw this guy with 7 meters per second, I'm throwing this up by also 7 meters per second at the same time. As shown, which one will take less time to reach the ground? Come on, let me know. Let me know. I'll come to which books to use, Vaibhav, soon, but not today. There is going to be a separate session on how to study and all those things later on. The red one, the blue one. Come on, think about it. A or B? Or both same time? Papi Reddy says both same time. Okay, Arundhati, Creo, Harni, Sambhav say B. Achha. Okay, some of you are saying red, some of you are saying blue. Yes, guys, the answer is B. Very good, very good, excellent. And why is that so? It's very simple, guys. Come on. I needn't explain it so much, but still, I'll explain it to you. Oops. Yeah. Okay, so the thing is, when they reach the ground, B has to cover hardly any distance. So it will come here very quickly. This guy has to go up and then come down. So A will hit the ground later on. Understand that. So the correct answer for this question is the time taken by ball A is obviously more than the time taken by ball B. I hope this is clear. Now this is obvious. Now let's go ahead and see the next part. Which one do you think will impact the ground? Okay, if they impact the ground with a higher speed, B or A? Come on, think about it and let me know. Come on, Chandan, keep it up. Please buck up your speed, Chandan. Come on, come on, come on. Okay. Well. We have a lot of varying answers. Wow, look at the chat box. Everybody's fighting. No, mine is correct. Oh, no, mine is correct. Who is correct? Well, let's see. Guys, just some time back, I told you the property of symmetric nature of vertical motion, vertical free fall motion. So according to that, please understand that if B has some velocity, example V1, okay? So B has some velocity, let's say V1 over here, and then when it hits the ground, it hits it with certain velocity, let's say V2. Okay, it is thrown with velocity V1, it hits the ground with velocity V2. Now, if you look at this ball A, it is also thrown with the same speed. It is given in the question with the same speed. So, direction is opposite. What will happen? It will go up and come down over here. And when it comes down, won't it have the same speed over here? Won't it have the same speed I just told you guys? So won't it do the same thing what B did just some time back? It will accelerate the same way, and by the time it reaches the ground, won't it have the same speed? Use the property of being symmetric. So yes, both will hit, but not at the same time, of course, but both will hit with the same speed. Understand that. Is that clear? Excellent question this is. Okay? Okay, great. Let's go ahead. Let's solve this question. Let's solve this question, guys. Very interesting question. This reminds me of some very nice songs like Tip Tip Barsa Pani and all that. But anyways, so the most annoying sound for a human being, one of the most annoying sounds, is the sound which you get when the water is dripping from a tap, and it's very irritating. Isn't it? Let me know. Yeah? Momal, please put up your doubts maybe in the comments. Okay, maybe. Okay. Great. So because there's so many people, Mohammed, I hope you understand. So please follow me. Okay. Okay, great. So let's solve a problem on that. So there is a tap which is at a height of 45 meters from the ground. Water leaks from it in the form of drops at regular intervals of time t. So after t seconds, a drop comes. After more t seconds, another drop comes. So every t seconds, there is a drop coming. When the first drop is about to hit the ground, the fourth drop is just leaving the tap. Interesting. When the first drop is just hitting the ground, the fourth drop is just leaving the tap. Question is, what is the t? Matlab, the time interval between successive drops. Very interesting question. Let's have a look at it. Okay. Now, let's visualize. This is my first drop. It has started. Just observe, this is my first drop. Okay? Pay attention. Do not get carried away. Just after t seconds, this drop is going to come here. And the second drop is just going to be near the tap. This is the second drop, this is the first drop. So first drop was earlier here, it came down, and the second drop is there. After more t seconds, this first drop is going to come down. And the second drop is going to be here, the third drop is going to be here. But these distances won't be equal, of course, because the more below you go, you will see the speeds increase and the distances will be more. And after more t seconds, this first drop is going to reach here, and the fourth drop will be here. This is third, this is second, and this is first. So let's start solving the problem. Here is what I'm going to do. Here is what I'm going to do. Observe this. Right from here till here, let's see how much time did the first drop take. This is first, this is second, this is third, and this is your fourth drop. Right from this situation till this situation, how much time did it take? So that time, so time by first drop to, I will say, reach the ground, how much will it be? Which formula do I use? Root of 2h by g. Yes, h is known, initial speed, do not forget, u is going to be 0. So this is that height which is given to be 45 meters. So I can use that formula root of 2h by g. So let's use that, and what will I get? Root of 2h by g, which is root of 2 multiplied by 45 divided by 10. 245 will give you 90, 90 by 10 will give you 9. So therefore time will be 3 seconds. Interesting. 3 seconds. That's the total time. But understand that's for the total event. Now just visualize. Pay attention to detail. First drop is already here. Okay, first drop, let's say, is here. From here to here, it will take t seconds. From here to here, it will take more t seconds. From here to here, it will take more t seconds. So t, t, and t. So although there are 4 drops here, but there are only 3 intervals. Understand. It's not 3 by 4. A lot of people are writing 3 by 4 wrong. It is 1 second, 3 by 3. Understand. I'll repeat again. See, just visualize. The first drop is here. Just imagine that. Time is 0 right now. Okay? The first drop is just leaving the tap. Time is 0. T seconds elapse, it comes here. So t. More t seconds elapse, it comes here. More t seconds elapse, it comes here. So t, t, t. How much is it? 3t. So 3t intervals are done. So guys, this value of t is going to be 1 second. Understand that. There are 3 intervals. There are 4 drops, but each drop to next drop is 1 interval. So that's why it is 1 second. I hope this is clear. Well, welcome Vidya Aurora. Don't worry which standard you are, as long as you enjoy physics. Amazing? Okay, great. That is the first answer. Now let's go to the next part of this question. So the answer was 1 second. When the first drop is hitting the ground, how high is the second drop from the ground? Wow, what a question. Try to visualize it. If you are having a pen and paper, try and drawing it and see what it means. Now what it means. Very good, Vidhi, you love physics, very good. Now, see, the thing is, the first drop is here, the second drop is here, the fourth drop was there, this is where the third drop was. Why can't we just find how much is this distance? Matlab, from the tap's opening, right? From the tap's opening till this point. Let's find this distance. Let's say I call it h. And then I can find out how much this is, because I know the total is 45 meters. That's given in the question. 45 meters above the ground. So let's find this, and for finding that, let's use u is equal to 0. So that's what I'm going to use. Okay, some of you are writing the answers. Some of you are writing the answers already. Okay, let's see who gets it correct. So here is the thing, guys. To find this h, which equation do I use? Think about it. U is known. Gravity is downwards, G. Okay. And let's take downwards as positive. Okay. So which equation do I use for finding this h? Yes, the second equation, S is ut plus half at square. Let's use that quickly. So S is ut plus half at square. S is h. U is 0. A is 10 because downwards is positive. Time, be careful. 1 second and 1 second. So 2 seconds. Do not use 3 seconds. No. From here to here is 1 second. From here to here is more 1 second. So total time is 2 seconds. Correct. I hope you get that. Now, how much will this be? 10 by 2 is 5. 5 into 4 is nothing but, come on guys, it is 20 meters. So h is 20 meters. So the only thing left in this problem is how much is this distance? Obviously, if I call this as x, this x should be 45 minus 20, which is nothing but going to be 25 meters. Then that's the correct answer. I hope you guys got it. Yes, a lot of people I have seen in the exam mark 20, they forget that the height was asked from the ground. Yes, from the ground. So pay attention to details, read the question very carefully. Okay, let's go to the next part. Let's look at the graphical way of looking at vertical free fall motion. Yes, very good, very good, very good. Very good Anumit, Papi, Harni, Santosh. Very good Kirto, very good Vasudevan, very good Arundhati. Very good. Yes, Mayank, this is for JEE Advanced. Thank you, Navmi. Okay, very good, Sudharti. Okay, don't worry, Gabdolkar. This will become easy if you practice more and more problems. Now, how do you look at the graphs? Let's quickly look at the graphs. How do you represent the motion of free-falling objects using graphs? First, position time. If you drop a ball from height h, how will the position graph look like? See guys, initial position is h if you measure it from below. And slowly, you will see that the ball starts coming down. So the position value keeps reducing, reducing, reducing. And finally, after some time, you will see the position becomes 0, assuming that I'm measuring the position from the bottommost point. It is a curved graph. It is a curved graph. The reason for it to be a curved graph, guys, is because the acceleration is there. Velocity is not constant. It will not move the same distances in the same time. So if it was moving with constant speed, then yes, this graph would be a straight line. This is position versus time. But this is, understand, the graph will be curved because it is accelerating. Very good. Okay, so this is how the graph looks like when an object is dropped from height h, assuming the position is measured from here below. Okay, now the next graph, same for position time, but when you throw a body up and it goes up and comes back, how will it look like? When you throw a body up, how will the position versus time graph look like? Think about it. Initial position will be 0. The position value will increase, 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 and it will come down, and finally the position will be the same. So it will look something like this. It will start from 0. The value of the position increases. It reaches maximum height h, and then the value of position decreases. If I had to mark certain values over here, then understand that this value will be actually h, and this value over here will be the time of flight. This t, which is same as 2u by g, and this h, which is same as u square by 2g. It will be a parabolic graph, guys. This is a parabola, and the reason why it is a parabola is because if you use the second kinematic equation, S is ut plus half at square, the t square is there. And you have learned today, I think, in quadratic expressions, that whenever you have a quadratic graph, it is a parabola. Understand? So it is a parabolic equation, a parabolic graph, because the acceleration is constant. That's why the displacement will be S is ut plus half at square. So there is a t square term over there, and that's why the t square will make that graph look like a parabola. This maximum coordinate is the maximum height. This below is when the position again becomes 0. That is your time of flight. Okay? So that's that's your graph of position versus time. Now, how about velocity graphs? Let's look at velocity graphs. Okay, velocity graph for a ball dropped from the top. How do you think it will look like? A ball dropped from the top. Think about it. It starts with zero velocity. It starts with zero velocity and velocity keeps increasing. And let's take upwards as positive. If I take upwards as positive, since it is going down, the velocity will increase negatively. So it's going to be a straight line. Why is it going to be a straight line? This is velocity, not position. So velocity increases uniformly. So that's why it's a straight line. Understand that. So magnitude wise it is increasing, but if you account for the sign, because it is going down, so I'm taking upwards positive, downwards negative, so it's becoming more and more negative. Understand that. Similarly, for a ball which is thrown up, what will happen? Initially, the velocity will be there. Slowly it becomes zero. And if I take upwards as positive, well, it should be positive first. It should become zero. And then it should become negative because while coming down, the velocity is pointing downwards. Look at that. It's a constant slope graph. The slope, the steepness is the same because acceleration is constant. Yes, acceleration is constant, guys. So that's why the velocity decreases uniformly. And it starts from a value which is positive. When you throw it up, it reduces, becomes zero at the topmost point. This is this point, and then it becomes negative while it is descending down. I hope this is clear. And now, how about acceleration time graph? Yes, y is equal to mx types. Yes, Ananya. Yes, Kaushik will be doing advanced questions soon. How will the acceleration time graph look like? Think about it. I just told you some time back, acceleration is a constant. So it will be just a constant value and it will be negative if I take upwards as positive. Yes, guys, understand this graph. Okay, be careful. If this is zero, here the value will be minus 9.8 meters per second square. It will be a negative constant, assuming upward direction as positive. It will be constant even while going up, coming down, even when you just throw it from the top, doesn't matter what it is, our acceleration is always constant. So we have seen how these graphs look like. Okay, so remember all these things. Remember. So that's what we did today. Tuesday, we have completed motion under free fall. Tomorrow, we are going to start kinematics, applications of derivatives. Yeah, derivatives application in kinematics. That's what we are going to do today. And I am going to provide you the assignment for free fall, which is called as flash drills. So check out the description box below. Also check the comments. Also check the Telegram group. It's also there in the description box or comment box below. Check it out. Join over here. Reason is you'll get all the updates, the PDFs of all the notes. Yes, we are going to give you all the notes. Whatever I did today, all those are available in PDF in the Telegram group. If you want to miss it, it's your choice. So all the notes are available. Not just that, the assignment for today is also available. The discussion will happen tomorrow. It's going to be a recorded session. So mind it, because I have to prepare for the next class and all that. So I hope you understand that. Okay, and do not forget to like, share and subscribe. And I've told you why you should give me that energy and why you should spread the joy of learning and why it's important to get notified so that you do not miss anything. Yes. So guys, did you enjoy today's session? How was it? How was it? Yeah, it was good. Amazing. Amazing. Yo guys, thank you very much. Thank you for tuning in. I am really glad. Stay safe, stay at home and stay protected, guys. Bye bye. Take care. Good night. Signing off.